All right, sorry about that. So we are drawing Fischer projections. All right, so we want the enantiomer of each of our following. So remember, enantiomer means that mirror image with just all of the sides of our chiral carbons are going to be swapped. So, whoops, I'm going to cheat and I'm going to copy and paste. Now, what's going to be different, right? Everything's going to be the same except that things coming off the chiral carbon are going to be different. So I want to remove the things on the chiral carbon because we're just going to swap them around. Okay. All right, so now what do we need to do? We need to take everything that's here and we're going to put it here. So this is the easiest way to do it. I find this is the easiest way to do it. Hydrogen, hydroxyl, just put your oxygen first, oxygen first, oxygen first. Okay, and then on the other side, you just need to look at what's there, right? Hydroxyl, hydrogen, 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 and that's it. So if this one is D-altrose, because we look here and we look at our farthest chiral carbon and we look at our hydroxyl is on the right. That gives us the D enantiomer. Well, here we're going to look, we go to our farthest chiral carbon, it's on the left. So this must be L-altrose, okay? All right, let's see, we got another one. I'm gonna cheat again. So just copy everything except you're just gonna change the stuff that's attached to those chiral carbons. So I'm gonna go in and erase. Okay, be careful not to erase the things that are up here. Let's see if I can highlight them. Don't erase any of this. Don't erase any of this. Leave that alone, okay? All right, now I'm gonna take everything that's here and I'm gonna put it here. So hydrogen, 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 hydroxyl. Then I'm gonna take everything here and I'm gonna put it over here. So hydroxyl, 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 hydrogen. That's it. So this one, if we look, right, if we look at our farthest chiral carbon, we're on the left, then we must be L-talose, right? Okay. All right, now draw the Fischer projection for the enantiomer mirror image of each of the following. So look at this one. What should you notice about this one? This one has two R groups, so this is a ketone, right? And so remember we talked about that with fructose. Okay, so, oh, but this is the one I'm doing in class. Gotta skip ahead. All right, classify structures A, B, and C in the figure as being either an enantiomer or a diastereomer. Remember what I said, write yourself a little note so that you know what's what before you do it. So if it's an enantiomer, then we know it is a mirror image. Mirror image, right? If it is a diastereomer, we know it's got all the same groups. Everything's the same except some of those chiral carbons, your sides are swapped, right? So you have one or more, but not all, chiral carbons are different, right? But these are not mirror images, not mirror images. Okay, so let's look at this. We got D-galactose. So what I want to do is I want to compare. So I'm going to compare my first chiral carbon. So my first chiral carbon, whoa, that's swapped. So let me just circle it on the one we're comparing. That way I don't have to erase all the time. So this one swapped. The next one, carbon 2. Oh, carbon 2 is swapped. Carbon 3 is the same. Carbon 4 is the same. So is it a perfect mirror image? No. So this must be a diastereomer. Okay, next one, chiral carbon 1. It's not carbon 1, it's chiral carbon 1. Or you could say carbon 2, either one. All right, so our first chiral carbon, we're the same. Our second chiral carbon is the same. Third chiral carbon is the same. Fourth chiral carbon is different. So this is a diastereomer. Okay, our next one, our first chiral carbon, they're flip-flopped. Ooh, No, it's not supposed to be a check. It's supposed to be a circle. They're flip-flopped, okay? The second chiral carbon, we're flip-flopped. Third chiral carbon, we're flip-flopped. Fourth chiral carbon, we are flip-flopped. So if they're all flip-flopped, what that means is that they are mirror images. And if you read down the side of one, so if we read down going this way, hydroxyl, hydrogen, hydrogen, hydroxyl, and if we read down on this side, we should get the same thing. Hydroxyl, hydrogen, hydrogen, hydroxyl, and we do. So that is an enantiomer. Okay. All right, that's for class. Use the structure to answer the following. So I went ahead and put the structure for you. Draw the Fischer projection of the carbon-3 epimer. So what does that mean, the carbon-3 epimer? Well, if it's an epimer, then it means one or more are different. Well, it's telling you in this question that it's a carbon-3 epimer. So I'm going to count my carbons. 1, 2, 3, 4, 5. Make sure, oh, and 6. Haha, don't forget that last one. So I want an epimer, but only of carbon-3. Remember, an epimer only means that one of the chiral carbons is different. So my third chiral carbon is what I need to change. So I'm going to go ahead and I'm going to erase my sides on my third chiral carbon, and I'm going to replace them. I'm going to just flip-flop them, right? So that we now have H and we have OH. Okay, so that is our carbon-3 epimer. Draw the Fischer projection of L-galactose. L-galactose. So if I want, this is D-galactose. So D-galactose, what do I know? I come down. I know that my last group, I should have my hydroxyl on the right. So all I need to do is go in and change that. I need to change, right? So that changes all of my other groups. So be careful that you don't just change that one carbon, you change all of the chiral carbons. Okay, so now what I want to do is I want to start out where I have my hydroxyl, whoa. I want to start out where I have my hydroxyl on the left side. So that will make it L-galactose. But I have to, wherever my hydroxyl is, I have to keep it with all this other stuff. So then it would be hydrogen, hydrogen, hydroxyl, okay? So this is that mirror image. So then we're just gonna do the other side, OH, OH, and H, okay? And so that is our L-galactose, right? All right, and I think, oh, we got a few more, right? All right, now, identify the monosaccharide that fits the following descriptions. So this is all just straight from the notes. Also referred to as dextrose. Dextrose, D-glucose is dextrose. Fruit sugar. Fruit sugar. Remember, all of this stuff that we're used to eating is in the D form. So make sure you put that D. D-fructose, right? Fruit, F-R-U-I-T, goes to fructose. Used to treat urinary tract infections. Urinary tract infections, again, is the D. It's natural in those cranberries. Mannose. Mannose. Okay, that's for class. All right, 21. Indicate whether the statements below apply to the hormone regulating, apply to the glucose regulating hormone, insulin, or glucagon. Remember when we had kind of our graph of our blood sugar, what's happening right here at the top? We're producing insulin. And then here at the bottom, we are producing glucagon, right? So kind of remember that. Signal cells to take up glucose. You only want to take up glucose if your blood sugar levels are high, so that is going to be insulin. Signals liver to produce glucose. You don't want your liver cells to make glucose unless you don't have any in your bloodstream. If you don't have any in your bloodstream, then you're going to be making glucagon. Okay, not produced in people with type 1 diabetes. In type 1 diabetes, people do not produce insulin or produce too low of levels of insulin, either one. All right, and that is it. Have a great day.